Hi, today we're looking at Functional Skills Maths Level 2. We've got the AQA exam board. This is the February 2023 paper, and we're going to start with the non-calculator section. Question 1. Here are 6 numbers. We've got them here. Work out the median. Circle your answer. Well, the first thing we want to do is make sure that they're sorted in order. Either smallest to biggest or biggest to smallest, doesn't matter. We've got 10, 13, 13, 15, 18, 21. Right, so these are getting bigger, but they're in order, that's fine. So we're going to cross off the smallest and the biggest, and the next smallest and the next biggest. And we carry on in doing that in pairs until we've either got one number in the middle, or in this case, we've got 2 in the middle. So what we need to do is we're going to need to add them together and then divide them by 2. Okay, so we've got 13 and 15. So 3 plus 5 makes 8. 1 plus 1 is 2. So we've got 28 on the top, and now we need to divide that by 2. So 28. We'll divide it by 2 using the bus stop method. 2 goes into 2 once. 2 goes into 8. 2, 4, 6, 8. That's 4 times. So we get an answer of 14. Question 2. Work out 7 plus 3 squared minus 6 times 4. So we've got to think of our order of operations. Now we always do whatever's in the brackets first. If you know your BIDMAS acronym, then the B stands for brackets. So we do that first. So 7 plus 3. We'll start with 7, we've got 8, 9, 10. So the bit in the brackets is now 10. We've still got the squared sign, and then we've still got the minus 6 times 4. Now the next thing that we need to do, any indices, well that's this squared sign. So we've got to do the squared bit now. Well, 10 squared means 10 times itself, times 10. Multiplying by 10, you just put a 0 on the end. Okay, so we've now got, instead of a 10 squared, we've got 100. And we've still got minus 6 times 4. Now the next thing we need to do is the multiplication. So not the minus bit first, but we're doing, or subtraction, but the multiplication bit here. So we need 6 times 4. 6 fours, we've got 4, 8, 12, 16, 20, 24. So we then substitute that for the 24. So we've got 100 minus 24. Okay. Now we can do this as a column. There's other ways you could do it, but I'm going to do it this way. 0 minus 4. Well, we can't take 4 away from 0. We've got nothing to use here, so what we're going to have to do is reduce this 1 to a 0 and pass our 1 across. So we've now got 10. We still want to get something over here to take the 4 from, so we're going to do the same again. We're going to reduce that by 1, so the 10 now becomes a 9. And now we've got 10 here. So 10 minus 4 gives us 6. 9 minus 2 gives us 7. So we've got 76. Question 3. Work out the size of angle X here. Well, I know that the total angles around a point are 360 degrees. We know one angle here is 167 degrees. This little square means that we've got a right angle, and a right angle is 90 degrees. So what we can do is if we add these two together, take them away from 360, we should be left with X. So let's do this bit first. Let's do the 90 plus 167. Okay, 0 plus 7 is 7. 9 plus 6 is 15. 1 plus 1 is 2. 257. Okay, so we're going to take that away from the 360. 0, take away 7 we can't do, so we're going to borrow 1 from the 6. So we reduce that down to a 5 and make this a 10. 10 minus 7 is 3. 5 minus 5 is 0. 3 minus 2 is 1. So we've got that x is 103, which we can write down on our answer line. Question 4. Work out 3.762 divided by 9. Well, I'm going to use the bus stop method. So the 3.762 goes in the bus stop, 9 on the outside. Okay, it doesn't matter we've got a decimal, we're just going to treat it as if this was just one big number. But what we will do is we will also have the decimal point in the answer as well in the same position. So 9 into 3, well 9's bigger than 3, so it's going to go 0 times. But we haven't used the 3, so that means we carry it across. What about 9's going into 37? Well, we've got 9, 18, 27, 36. So that's 4 times with 1 remainder. About 9 into 16. Well, 9. 2 9s would be 18, which is too much. So it's just going to be once is 9. And we'd have 10, 11, 12, 13, 14, 15, 16. So that means 7 left over. And 9's into 72. Well, we've got 9, 18, 27, 36, 45, 54, 63, 72. So that's 8 times. 0.418. Question 5. The probability of an event happening is 83%. What is the probability of the event not happening? Well, it can either happen or not happen, and in total, it's going to add up to 100%. Okay, because there's no other options. So what we need to do is start with 100% and subtract our 83% to tell us the probability of it not happening. Again, you could count up from this one instead. In fact, we'll do it this way, then I'll show you how you can count up instead. So again, we can't take 3 away from 0. We've still got 0 here, so we need to reduce the 1 to a 9, make that a 1, reduce the 10 to a 9, make that a 10. So we get 10 minus 3 is 7, 9 minus 8 is 1. Why did I reduce that to a 9? I should have reduced that to a 0, of course. 1 minus 1 is 0. So we're just left with 17. 17%. Okay. Now, what we can do here instead is we could count up. So we could start with 83 and say, well, what do I need to get it up to the next 10? So what would we need to get it up to 90? Well, it'd start at 83, it'd be 84, 85, 86, 87, 88, 89, 90. So that would be 7. And then we want to get it up to 100. Well, 100 is just adding 10 onto it. So 7 plus 10 is 17. So either way, you get 17%. Question 6. Calvin is making fudge. A recipe needs 9 ounces of butter to make 30 pieces of fudge. Calvin wants to make 40 pieces. He has 175 grams of butter. How much more butter does he need? Give your answer in grams. And they're telling us that we can use 1 ounce equals 25 grams. Okay, so let's think about this. So we've got ounces and we've got pieces. So I'm going to do this as a bit of a table for us. You know, we've got 9 ounces, gives us 30 pieces. So what we'd like to do is work out how many ounces we're going to need for 1 piece. Okay, now to get from 30 to 1, well, really we're dividing by 30. So we need to do the same over here. We want to do 9 divided by 30. Now at first, that might look like not a very nice thing to do. But if we think of our bus-stop method, remember it's the first number that goes inside, and we're dividing it by 30. Okay, now what I'm going to show you here is, well, we've got, instead of 9, we can think of this as 9.0. Okay, so we're saying, well, 30 doesn't go into 9, so we can put 0. What about 30 into, if we carry the 9, 30 into 90? Well, we can cancel the zeros and we can just say 3 into 9. And 3, 6, 9, that goes 3 times. So we've got 0.3 ounces for one piece. Now we want 40 pieces. So if we give us some more space, what we want to do is our 0.3 times 40. Now what I'm going to do here is I'm going to do it as just 3 times 40 to start with. Okay, so I'm ignoring the 0 point. So 3 times 0 is 0. 3 times 4, 4, 8, 12. So we get 120. Now we want to put the decimal point back in. So 1 decimal place. So we put 1 decimal point in there. So we've got 12. So what this is saying is we have got 12 ounces for 40 pieces. Okay, so we've got it in ounces. We want to get up to grams though. So we need to multiply our 12 by 25 grams. Okay, let's do this as a column, so we can have 12 times 25. 5 times 2, or 2 times 5 is 10. 1 times 5 is 5, plus 1 is 6. Okay, now on to the next row. So we're going to put a 0 here, because we're multiplying by 10, so we won't have any units. 2 times 2 is 4. 2 times 1, or 1 times 2, is 2. So if we add these together, 0 plus 0 is 0. 6 plus 4 is 10. 2 plus 1 is 3. So we have got 300 grams for 40 pieces. Right, he's already got, if we look back up here, 170 grams of butter. We want to know how much more he needs. So what we're going to do is we're going to start with our 300 and we're going to subtract the 175 grams of butter he's already got. So we want to take 5 away from 0. Again, we can't take it from 0. We've got nothing here to help, so we reduce the 3 to a 2, which makes that 10. We still want something over here, so we reduce the 10 by 1 to a 9. Make that a 10. 10 minus 5 is 5. 9 minus 7 is 2. 2 minus 1 is 1. So we've got a final answer of 125 grams. Now, if you don't like this division, you could do it differently. You could convert it into grams to start with to get you a bigger number. It might make the division a little bit nicer, but essentially you're going to be going through the same type of steps here. You just might do them in a different order. (6b). Calvin makes the 40 pieces of fudge. He covers 14 of the pieces in white chocolate, the remaining pieces in milk chocolate. What fraction of the pieces does he cover in milk chocolate? Give your answer in its simplest form. So first we want to know how many pieces he covers in milk chocolate. So we want 40 minus 14. Again, I'm going back to doing everything as a column. You don't have to, but it's the most straightforward way for me. I can't take 4 away from 0, so I'll reduce this to a 3 and make that 10. So 10 minus 4 is 6. 3 minus 1 is 2. So that means we've got 26 pieces of milk chocolate. They want it as a fraction, so it's going to be 26 out of the original 40. Okay, now they said in its simplest form. So we need to find at least one common factor of these two numbers. Well, they're both even numbers, so I know that we can divide them both by 2. So let's try 26 divided by 2. 2 goes into 2 once. 2 goes into 6. 2, 4, 6. That's 3 times. So we can make that 13 on the top. And we want 40 divided by 2. 2 goes into 4. 2, 4, that's twice. And 2 goes into 0, no times. So I've got 13 over 20. Are there any other common factors of 13 and 20? Well, obviously 1 is a common factor, but that's not going to help us to simplify it. And that's as far as it's going to go. I know that because 13 is a prime number, so we're not going to be able to make it any smaller. So we can put 13 over 20 on our answer line. Okay, 6C. Calvin put some of the fudge into a gift box. The box is a triangular prism, and we've got a picture of it there. To work out the volume of the box, he follows these steps. So step 1, work out the area of the triangular face. So that would be this bit here. And then step 2, multiply the answer to step 1 by the length of the box. So working out the area of the triangle, multiplying by the length. For this box, each piece of fudge needs 10 centimetres cubed of space. How many pieces of fudge can Calvin fit in the box? Okay, so let's use these, step 1 and 2. So the area of the triangular face. Well, the area of a triangle is half times the base times the height. Okay, so in this case, we've got half times, well, let's keep it like this. So half times the base, which is 6, and then multiplied by the height, which is 8. Okay, well, half of 6 is 3, and then we've still got the 8 to come. So 3 times 8, we've got 8, 16, 24. So that's the answer for step 1. Now, step 2, multiply the answer to step 1 by the length of the box. Okay, so step 2 over here, we've got 24. We're going to multiply that by the length, which is 9. So let's do this way. So 9 times 4, or 4 times 9, we're going to have 9, 18, 27, 36. And 2 times 9 is 9, 18, plus 3 is 21. So we're at 216. Right, so we've got 216 centimetres cubed. That is our volume. Now, if each piece of fudge needs 10 centimetres cubed of space, we want 216 divided by 10. Well, if we're dividing by 10, we think of the decimal point at the end of the number, and we're just going to move it in once to make it smaller. So we've got 21.6, but we can't have 0.6 of a piece of fudge, so we're going to have 21 pieces of fudge. And we can write that down here. And that's the end of the non-calculator section. So now we move on to the calculator section. Question 1. Circle the largest number. Okay, so we could rank these or write them in order and have a look at them that way. Sometimes it helps to add, because we've got 3 decimal places on these, we could put zeros on the end here so that we've got 3 decimal places for all of them. So because they're all starting with a 2, we can just say, well, we've got 400, 410, which is bigger. 396 is smaller. 409, well, that's still smaller. So that's going to be our biggest one there. Okay, question 2. And we'll move this up a little bit. Write the number 2,408,000 in digits. Okay, so use the commas here to help. So 2 million, so 2,408,000, so 408,000. And that's it. Now, we had the 1,000. We've got to put something here. Well, we've got no hundreds, no tens, and no units. So we need to have these included. So 2,408,000. That's it. Okay, question 3. Write the ratio 150 to 240 in its simplest form. Okay, well, so what that means is looking for common factors. Well, they both end in a 0, so we can cancel those off. So we've got 15 to 24. Right, so we want to think, what common factors have we got? So which times tables are 15 and 24 in? I think, well, I think 3 might go into both of those. So what I can do is I can check with my calculator. So 15 divided by 3, yeah, that's 5. And what about 24 divided by 3? That's 8. And I'm not going to be able to go any smaller than that. So 5 to 8. Question 4. A cube has side length 3 centimetres. Use the centimetre isometric paper to draw the cube. Now, a centimetre isometric paper, it just means that the points are lined up on a diagonal rather than horizontally. But we know because it's centimetre, it means the difference between each of the dots is 1 centimetre. Okay, so we're going to try and draw our cube here. So I'm going to draw, where should we start? Maybe right in the middle. I'm going to draw the top of my cube. So it helps to sketch it out first, actually. So if we think of a cube, we'd have a square on top, then one face on the left, one on the right. We wouldn't see the other bits because they'd be hidden. So we're only going to see the top, the left side and the right side. So if we start up here at the top, 3 centimetres, so we're going to want to go 3 squares that way. And we're also going to need to go 1, 2, 3 that way as well. Okay, now we've got to finish it, so finish this off. So we're now going to come down 1, 2, 3 to here, and we're going to close this. I say square, it doesn't look like a square, but it would be if it was in real life. And we'd have 1, 2, 3. So there's the top of our cube. So now we want these vertical lines, and they've all got to be 3 centimetres as well. So 1, 2, 3. 1, 2, 3. 1, 2, 3. And we can just join them up. And it should be 3 points each time. 1, 2, 3. 1, 2, 3. There we go. You don't have to position it exactly here, but it should still look like this wherever you put it on the grid. Question 5. Complete the table to show 3% as a decimal and a fraction. Okay. Well, 3% means 3 out of 100. Well, there's the fraction straight away. For the decimal bit, 3 out of 100, 0.03. Question 6. An object has mass 59.5 grams and volume 17 centimeters cubed. Work out the density of the object. Okay, so the density, well, this is the weight, but per unit of weight. So it's going to be weight per, it's going to be the weight for each bit of space. So it's going to be weight per centimetre cubed. So in other words, we've got the 59.5 and we're going to divide it by the 17. Okay. And we've got the clue here because they've told us that it's grams per centimetres cubed. And if you think of this, this is dividing. It's saying grams divided by centimetres cubed. So it's actually telling you exactly what to do. And because we can use our calculator, 59.5 divided by 17 is 3.5, which we can write down here. Okay, so sometimes if you're a bit stuck or you think, oh, looks complicated, I can't remember density, look at the units. That's going to help you out as well. Okay. Question 7. Calculate 7/8 plus 1/4. Give your answer as a mixed number. Okay, well, we've got different denominators, so we can't just add them as they are. But 4 goes into 8. So what we can do is we can change this fraction to make it also be over 8. So what we'll do there is, so we want 1/4. We want to write it with 8 at the bottom. As I say, I know 4 goes into 8, so that's why we can do it this way. And 4 goes into 8 twice for 8. So 1/4 is going to be the same as 2/8. So that means we can write this, we can keep the 7/8 the same, and we can replace the quarter with 2/8. And because the denominators are the same, we keep that there. 7 plus 2 gives us 9. Now they've said as a mixed number. So by a mixed number, they mean they want to know how many whole times it goes into it, and then how many are left over. Well, 8 goes into 9 once, with 1 remainder. So it's 1 and 1/8. Question 8. Isra has started running to get fit. One day, Isra ran and walked for 55 minutes in the ratio minutes running to minutes walking as 7:4. So every time they ran for 7 minutes, they then walked for 4 minutes. The table shows information about calories. So when they were running, they burned 16.2 calories per minute. And when they were walking, they burnt 5.8 calories per minute. Work out the total number of calories Isra burned in the 55 minutes. So we want to know the total amount of time that they spent walking and running, and then we can multiply them by these calories here. So let's do a little ratio table. So we've got running, walking, and then I'm going to have a total as well. So every time they run 7 minutes, they walk 4 minutes. If that's all we had, well, 7 plus 4 gives us 11. But actually they were going for a total of 55 minutes. So how are we getting from that row to that row? So we want to start with the 55 and divide it by the 11, which gives us 5. So this is being multiplied by 5, so we need to do the same with everything else. So 5 times 7 gives us 35, and 4 times 5 gives us 20. Right, now we can work out the calories. So running 16.2 calories per minute, so we're going to multiply that by 35 minutes of running. Okay, and the walking, 5.8 calories per minute, we're going to multiply that by 20 minutes of running. So 16.2 times 35 gives us 567 calories. I find it helps to write the units down sometimes just so you're understanding exactly what you're working out each time. 5.8 times 20 gives us 116 calories. So the total calories will be those two added together, which is 683 calories, which we can then write on our answer line. 8b. Isra wants to buy new running shoes. The price of the shoes is reduced in a sale. We've got a sale 30% off. Sale price is £84. By how much in pounds is the price reduced? Okay. Well, this is the sale price. It's already had the 30% taken off. So this actually represents, well, if you think you start with 100%, you take 30% off, so this represents 70%. So to work out how much has been taken off, we need to work out what the original price was first. So if this represents 70%, if we do 84 divided by 70, that's going to tell us how much 1% would cost. Which would be 1.2 or £1.20. We want to know what the full price was, so we want to know what 100% was. So the shoes were actually £120 to start with. We want to know what 30% of that was, so we want 30 out of 100 times 120. Which gives us £36. There you go. So the trick with this one is recognising that this has already had the 30% taken off. Okay, so we don't want to work out 30% of this, it's not going to be right. We need to work out what the original was, or work out what 1% was. We could have then just multiplied this £1.20 by 30 and got straight there, but I think it makes more sense to work out the total and work out 30% of that. 8c. 180 runners take part in a race. Each runner completes either 3 kilometres or 5 kilometres. The two-way table shows information about the runners. Okay, so in both the 3 kilometre and the 5 kilometre, you could have children or adults. And we're told a runner is chosen at random. Isra says the probability that the runner is an adult in the 5 kilometre race is less than 0.55. Is she correct? You must show your working. Well, to do that, we're going to have to find the numbers in here first of all, because we don't know how many adults did the 5 kilometre race. So let's fill in these gaps. Well, we know that there were a total of 180 runners. 70 did the 3 kilometre. So the 5 kilometre would be 180 minus 70. Which is 110. Now, if there's 110 in total, 13 of them were children, the rest must be adults. So this one is going to be 110 minus the 13, which is 97. And just to finish it off, if this is the total number of adults, well, it's going to be the 97 here, plus the 24 that did the 3K, which is 121. And if we want to check, the 121 plus the 59 should give us 180, which it does. Right, so now we work these out, we can actually answer this. So the probability that the runner is an adult in the 5 kilometre race. So, well, we've got 180 people in total that we're looking at. And we want an adult in the 5K. So adults are here, 5K here. So this is the number we want where they cross over. So we've got 97 out of 180. So if we do this on our calculator, it will give us the answer as a decimal, which is 0.5388, blah, blah, blah. Okay. Well, what I can see is that is definitely less than 0.55. So is she correct? Yes. Okay, question 9. Are we going to be able to fit this all on the screen? We'll try. Buying a house. Jack is renting a flat while he saves to buy a house. 9a. Jack rents a flat in town. The table shows information about the rent of 20 other flats in the same town. Okay, so there are 5 flats with rent between £550, 6 flats with rent between £550 and £600, 7 flats between £600 and £650, and 2 flats which have got rent of £650 to £700. Jack pays rent of £637 per month. How much more than the estimated mean of these 20 flats does Jack pay per month? So what they want us to do is to work out the mean. Okay, and then we can compare it to what Jack pays. Okay. So we know that the mean is the total divided by the frequency, or how many there are. Okay, now the starting point with this, to work out the total, well, we want to multiply this frequency of 5 by the rent, but it's a range, this rent. It's between 500 and 550. So we're going to, this is the estimating bit. We're going to estimate that the rent for this range was right in the middle. And the way that we do that is that we add up the smallest value with the biggest value and then divide it by 2. So 500 plus 550 divided by 2 is 525. Now we're going to do this with all the other ranges. So 550 plus 600 divided by 2 is 575. You might see a pattern actually with this, so you might be able to shortcut it. Oh, not minus anything. Let's start that again. 600 plus 650 divided by 2, 625. And then 650 plus 700 divided by 2, 675. So now we've worked out the midpoints, we can forget about all of this. Okay, we're still trying to work out our total, remember, the total amount, and we're going to do it one range at a time. So we're going to say if there's 5 flats with rent of £525, well, we're going to need to multiply those together to get the total. And we're going to do it with all of these ranges. Okay, so let's start up here. 525 times 5 is 2,625. 575 times 6 is 3,450. 625 times 7 is 4,375. And 675 times 2 is 1,350. So this is the total amount of rent for each of the ranges. If we want the total overall, we need to add them all up. 2,625 plus 3,450 plus 4,375 plus 1,350 gives us a grand total of 11,800. So 11,800 divided by 20 gives us £590. Now they asked us how much more than the estimated mean does Jack pay per month. So they knew that the mean was going to come out below his amount. So that's good. That shows that we've done something right there. So we need to do the 637, subtract the mean, which gives us £47. And we can then write that down on the answer line. (9b). Jack plans to save a total of £18,000. I like to put my commas in so I can read the numbers more easily. He has already saved £13,200. He will save the rest from his monthly salary of £1,600. And he will save the same amount each month for 24 months. What percentage of his monthly pay does he need to save? Okay, so he plans to save a total of 18,000. He's already saved 13,200. So how much more does he need to save? So 18,000 minus 13,200 means he needs to save another £4,800. Okay. Now he's going to save it over 24 months. Okay, so we want to divide this by 24 to find out what each monthly payment will be that's going into his savings. 4,800 divided by 24 is £200. Right. What percentage of his monthly pay does he need to save? Well, so he needs to save 200 and his monthly salary is 1,600. So it's going to be 200 out of 1,600. They want it as a percentage, so we're going to multiply it by 100. So 200 divided by 1,600 times 100 gives us 12.5%, which we can put down here. (9C). Jack takes a second job. He works each Saturday from 9 a.m. to 12 noon and from 1 p.m. to 5 p.m. He earns £13.50 per hour. 1/5 of his pay is deducted for income tax. How much does Jack earn each Saturday after income tax has been deducted? Right, well, so let's see, how many hours does he work for, first of all? Well, 9 a.m. to 12 noon. So from 9 to 10 to 11 to 12. So that's 3 hours. And then from 1 p.m. to 5 p.m. So from 1 to 2 to 3 to 4 to 5 p.m. That's 4 hours. So a total of 3 plus 4 of 7 hours. And he earns £13.50 an hour. So 7 times £13.50 is £94.50. We need to put the 0 on because it's money, so that we've got pence. Now 1/5 is deducted for income tax. So 1/5 of 94.50. Well, we can do 94.50, just divide it by 5 to get a fifth. So that's £18.90. So he gets £94.50, but £18.90 is taken away for income tax. So £94.50 minus £18.90 leaves him with £75.60, which we can put down here. Okay, question 10. Goats. Kira keeps goats. Kira needs a fenced area in her field for some of her goats. The fenced area will be a square that covers 81 metres squared, and in the northwest corner of the field. The centimetre square grid shows a scale drawing of Kira's field. Okay, and we're told 2 centimetres represents 3 metres. Draw the plan of the fenced area. Right, so we've got a few things going on here. First of all, we want to work out what is the size of the square. Well, we're told that it covers 81 metres squared. So we've got to think, well, what multiplied by itself gives us 81? But actually, we can use our calculator, because we can do 81 square root, which gives us 9. Okay, so this square is 9 metres by 9 metres. Right, that's good. That's a good start. We know it's in the northwest of the field. They've shown us the compass. That's north. If you remember, never eat shredded wheat. So northwest up here, so it's going to be in this corner, somewhere around here. Now we've got scale to use as well. We're told 2 centimetres represents 3 metres. Well, so how many 3 metres have we got in each of these? Well, 9 divided by 3 is 3. Okay, so what we're saying is for each square on here, so we're going to have, this is going to be 3 squares, but each one of them is 2 centimetres. So we need to multiply it by 2 centimetres. We can use a calculator. So 6 squares. Okay, so we're saying we need 9 metres, but actually 9 metres is going to be, we've got 3 lots of them, and then each of those is 2 centimetres. Okay, so we want 6 squares across and 6 squares going down. So let's move this up a bit. And northwest, we want it in this corner, so we're going to start in this corner. We're going to count 1, 2, 3, 4, 5, 6. And then we're going to go down 1, 2, 3, 4, 5, 6. And if we join these up, and the same at the bottom. And that's enough. We've done our picture. (10b). Kira has 48 goats that produce milk. On average, each goat produces 3.21 litres of milk per day. Using approximations, so we don't want to use exact numbers, estimate how many litres of milk in total the goats produce each month. You must show your working. Right, so we've got 48 goats. Well, we're going to say 48 is about, if we round it to the nearest 10, is about 50. And on average, each goat produces 3.21 litres. Well, 3.21, that's about 3. Okay, so how many litres are we going to have per day? Well, it's going to be 50 goats doing 3 litres each, which is 150 litres. They want to know per month. Well, they haven't said which month, but again, we're approximating. So we can say a month has approximately equal to 30 days. So if we do 150 times 30, we get 4,500, which we can put down here. (10c). Kira uses some of the milk from her goats to make soap. The soap is made into 2 different solids. To package the soaps, Kira needs to work out the surface areas. So soap A, we've got a cuboid here. And soap B, we've got a sort of a short cylinder. And we're told that, in fact, they tell us soap A is a cuboid with a surface area of 153 centimetres squared. And soap B is a cylinder with a radius of 5 centimetres and a height of 1.8 centimetres. So all of these measurements are on here. Here's a sketch of the net of the cylinder. Okay, so you can think you've got the top, you've got the bottom, and this is the bit going around the side, all stretched out. Now we've got the question over the page. Kira says the surface area of soap A is less than 3/4 of the surface area of soap B. Is correct? You must show you're working. So in other words, what we've got to do is work out the surface area of both of the shapes. Okay, so in fact, no, we don't, because we've got the surface area of SOAP A, so we just need to work out the surface area of shape B and compare. Right, so surface area. So we've got the net of SOAP B, so we just want to work out the areas of these shapes. Right, first of all, we need the area of a circle. And the formula for that is, not 2, it is pi r squared. Where pi, we can use 3.14. R is the radius, they've told us that's 5. Squared means times itself. So we've got 3.14 times 5 again. 78.5 centimetres squared. Now that's also going to be the same for this one, because we've got 2 of them. So in fact, let's write 78.5 cm squared and 78.5 cm squared. Now for this strip here, we need to know how long it is. Well, the length is actually going to be the distance around the circle. So we want the circumference now. So the circumference of a circle is equal to 2 pi r. And remember, when you've got numbers and letters next to each other, it means that you multiply them. So it's going to be 2 times pi, which is 3.14, times the radius, which is 5. So we get 2 times 3.14 times 5, which is 31.4 centimetres squared, which we can write on here. So we want our total surface area, and that's going to be of SOAP B, will be 78.5 plus another 78.5 plus 31.4. Uh, 78.5 plus 78.5 plus 31.4 gives us 188.4. And that's going to be centimetres squared. Okay, now, oh no, it's not. What we worked out here, this was the circumference. We need to multiply, sorry, that is wrong. That's the circumference. The area is going to be the circumference, 31.4, multiplied by the length, the 1.8. Oh, apologies for that. Shows how easy it is to make mistakes in these. 31.4 times 1.8 is 56.52. Right, so we're going to change that to 56.52, and we're going to change that because we need to work it out again. Right, now I could have just deleted this and done it again, but I think it's good to show that mistakes can be made, and it's about not panicking, checking things as you're going along, and if you spot something, we'll just correct it. Okay, so we get an answer of 213.52 centimetres squared. Right, now we can't stop there. Let's check what the actual question was. So, Kira says the surface area of SOAP A is less than 3/4 of the surface area of SOAP B. So we want to work out 3/4 of this. So we want to multiply that by 3/4. Still got it in my calculator. Times 3 divided by 4. We get 160.4. Now, she was saying that the surface area of SOAP A was less than this. Surface area of SOAP A is 153 centimetres squared. So 153 is less than 160.14. So we can say yes, she is correct. So quite an involved question here. Right. Question 11. Parcels. ML owns a company that delivers parcels. 11a. ML records the delivery distance and the time taken for 12 parcels to be delivered. The scatter diagram shows information for 10 of these parcels. So we've got the time in hours to deliver and the distance to delivery address in miles. Okay. Right. Now, I'll move this up. We're told the table, let's see all of the question, yeah. The table shows the data for the other two parcels. So one took 11 hours and to deliver it, it was 150 miles away. And the second one took 16 hours to deliver something that was 190 miles away. Plot the two extra points and then use the scatter diagram to estimate the delivery distance of a parcel that takes 14 hours to deliver. You must show your working, which should be on the diagram. State the units of your answer. Right, so let's plot these values first of all. So we've got 11 hours and it's 150 miles. So 11 is going to be halfway between 10 and 12. So here, and we want 150 miles. It's 150, so we're going to go up and put our cross in there. And the next one is 16 hours, so that's here, and 190 miles. Well, here's 200. If you think we've got 150 here, so what's each of these smaller boxes worth? Well, one of these full gaps is 50. So if we do 50 and divide it by 1, 2, 3, 4, 5 squares, we find that each small square is equal to 10 miles. So, going back to this one, 16, we want 190 miles. Well, if we go up to 200, 190 is just 10 less, so we're going to go back down one. Or you could have started at 150 and said 160, 170, 180, 190. Either way, we're going to put it across there. Now, we need to use this information to estimate some values. So to do that, we're going to have to draw a line of best fit on here. Okay, and what that means is it's a straight line that goes through the data, follows the overall pattern, so it's going to be going up to the right. And we want roughly the same number of points above as below the line. So something like that. Okay, it doesn't matter if it goes through any points. It can do, doesn't have to. Right, now, they want us to use this to estimate the delivery distance of a parcel that takes 14 hours to deliver. So 14 hours is here. Draw a line up and then a line across. And that's sort of right in there. So what distance would that be? Well, if this is 150, that would be 160. That would be 170. That would be 180. So I'm going to go halfway between 170 and 180 and say it's 175 miles, which we can write down on here. Now, you might get an answer that's different from this. A lot of that is going to depend on how you draw your line of best fit. They will give you a range of possible answers. So don't worry, so long as I say, it's a straight line, it doesn't go beyond the first and last point, and you've got roughly the same number of points above and below. (11b). ML uses this formula to calculate the delivery cost for a parcel. So we've got the cost in pounds is equal to 1.5 times the weight in kilograms plus 0.04 times the delivery distance in miles. A parcel weighs 4.2 kilograms and has a delivery distance of 85 miles. ML says the cost will be less than £10. Is he correct? You must show your working. Well, let's work it out. So 1.5 times the weight in kilograms. So it's going to be 1.5 times 4.2. Then we're going to need to add on 0.04 times the delivery distance in miles, which is 85. And if you remember your order of operations, the multiplication always comes before the plus. So if it helps, you can put brackets around these to show we're going to work out both of those first. And then, actually, let's put the plus in the middle, and then we'll do the adding. Okay, so 1.5 times 4.2 gives us 6.3. And then we're going to add on 0.04 times 85, which is 3.4, which gives us 9.7, or £9.70, and we can say £9.70 is less than £10. Is he correct? Yes, he is. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, make sure your notifications are turned on, and I look forward to seeing you again soon. Thank you.